You know, in the world of AI, we always hear about models getting bigger, more powerful, and let's be honest, way more expensive to run. But what if the next giant leap forward wasn't about getting bigger, but about getting a whole lot smarter and faster at the same time? Well, today, we're looking at a breakthrough that does exactly that.
So NVIDIA just dropped this new family of AI models. It's called Nemotron Nano 2, and it's already making waves, not just for how smart it is, but for its unbelievable efficiency. We're talking about a model that is somehow both a world-class marathon runner and an Olympic sprinter.
And when I say sprinter, I am not kidding. Just look at this. When you put it head-to-head with a competitor of a similar size on tasks that require really deep reasoning, Nemotron Nano 2 just blows it away, delivering up to 6.3 times the performance. That is a massive leap in efficiency. Which, of course, raises the big question for this explainer: how on earth did they pull that off?
Okay, let's dive into how they did it. First, we're going to talk about the big challenge they were trying to solve with AI reasoning. Then, we'll break down the 3 core innovations they came up with: a totally new hybrid architecture, a frankly insane 20 trillion token dataset, and a clever shrinking process called Minitron. And finally, we'll see how it all comes together.
So first things first, let's set the stage. For an AI to do something really complex, like solve a tough math problem or write a bunch of code, it can't just guess the answer. It has to think it through, step by step, right? It generates this long chain of reasoning. The problem is, that whole process is super slow and takes a ton of computing power.
Yeah, the NVIDIA team put it perfectly in their report. The whole game was to speed up these long thinking traces. You can think of it like the AI's internal monologue. The goal is to make that monologue happen way, way faster, but without losing any of the quality or accuracy in the final answer.
And that leads us right to their first big innovation. They came up with a completely new hybrid design for the model's brain. And trust me, this is not your standard AI architecture.
They did this by using a new kind of building block called a Mamba-2 layer. So imagine a traditional AI is like a team of geniuses who have to look at the entire problem all at once to get it. They're powerful, for sure, but they're slow. Mamba layers are different. They're like sprinters that process information one piece at a time, sequentially, which makes them incredibly fast for those long chains of thought.
And here's the really clever part. NVIDIA didn't just bet everything on one or the other. They built a hybrid. They used just 6 of those traditional self-attention layers, which are great for seeing the big picture, and then combined them with 28 of those super-fast sprinter Mamba layers. This mix gives the model the absolute best of both worlds: that deep, global understanding plus raw, sequential speed.
All right, on to the second pillar of this whole thing. Because, a brilliant architecture is only half the story. It doesn't mean much if you don't have amazing data to train it on. And the scale of what NVIDIA used here is, well, it's kind of hard to even wrap your head around.
20 trillion tokens. I mean, that's like reading billions and billions of books. But the really important thing here isn't just the jaw-dropping number. It's the quality and the diversity of that data.
See, this wasn't just some giant data dump from the internet. NVIDIA basically created a sophisticated curriculum for the AI. It's a carefully balanced diet of high-quality web text, tons of code, academic papers, data in different languages, and they put a special focus on math.
And one of their slickest breakthroughs was how they handled all that math. You see, pulling complex equations out of messy web pages is a huge headache for AI training. So they built a whole new pipeline using a text-based browser called Lynx and another AI, 5.4, specifically to go out, find, clean up, and standardize all that math content. This gave them a math dataset that's just way better than what people had before.
Okay, so we have a super fast architecture and incredible training data. But that actually created a new problem. The model they built was too big. And this brings us to the third big innovation: a process for smartly shrinking the model down without making it dumber. So check this out. The original model had 12 billion parameters, and it needed about 23 gigabytes of memory to run. The hardware they were targeting, a pretty common and accessible NVIDIA A10G GPU, only has 22 gigabytes. You can see the problem. It was literally too big to fit.
So their solution was this framework they call Minitron, and it's a 3-step process. First, it figures out which parts of the AI's brain are the least important. Then, it searches for the absolute best smaller design. And finally, this part is genius. It uses something called knowledge distillation, where the big original model literally teaches the new smaller model everything it knows. It's less like taking a sledgehammer to it and way more like a master sculptor carefully chipping away just the non-essential marble.
So you take this clever hybrid architecture,
Yet in the superior data, you top it off with this intelligent compression. You put all that together, and what do you actually get? Well, let's look at the numbers.
The final model, now down to 9 billion parameters, not only fits perfectly on that target GPU, but it actually smokes its competitor on these incredibly difficult reasoning tests across math, science, and coding. So get this, it's smaller, it's faster, and it's smarter.
And all this efficiency unlocks some really cool new features. One of my favorites is this thing called budget control. You can literally tell the model how many thinking tokens it's allowed to use for a task. If you need a super quick answer, you give it a small budget. If you need a really deep, well-reasoned answer, you let it think for longer. It's a level of control that just wasn't really practical before.
So, at the end of the day, the combination of this hybrid design, the massive high-quality data set, and the smart compression makes state-of-the-art AI reasoning more accessible than ever before. It's a huge step toward putting truly powerful AI into the hands of more developers, more researchers, more everyone. Which kind of leaves us with one final big question. With AI this powerful and this efficient, running on hardware that more people can actually get their hands on, what new possibilities are about to be unlocked?